Okay, what do we have here? What are we looking at? Got an equal sign. That's a clue that it's an equation. And the highest power of x in this equation is 2. So what kind of equation is this? We are looking at a quadratic equation. And this particular quadratic equation can be solved in a multitude of ways. We can factor the left side. What two numbers add up to 10 and multiply to negative 24? That will be a plus 12 and a minus 2. And so this would mean in order for this product to equal 0, one of these factors would have to equal 0. So x would have to equal negative 12. That would make this factor equal 0. Or x would have to equal 2. That will make this factor equal 0. All right, so now let's solve it using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we've got the opposite of b set to negative 10 plus or minus the square root of 10 squared is 100 minus 4 times a is 1, so it's 4 times negative 24. It'll end up being plus 4 times 24, which is 96. So divided by 2 times 1, which is 2. So we've got negative 10 plus or minus the square root of 196 over 2. That's negative 10 plus or minus the square root of, let's see, 196 is, the square root of 196 is 16. So plus or minus over 2. So we've got negative 10 plus 16 over 2. And negative 10 minus 16 over 2. Negative 10 plus 16 is 6 over 2, or negative 26 over 2. I have messed up. 196 is in 16 squared is 14 squared. Boy. Negative 10 plus 14 is 4. Negative 10 minus 14 is negative 24. 4 over 2 is 2. Negative 24 over 2 is 12. So x equals 2, or x equals negative 12, just like we got back here. Now we're going to solve it a new way by completing the square. This new method is called completing the square, and I can write so neatly, can't I? I wonder if my not completing. Completing the square is the method that I'm going to show you here. Okay, to get an idea of an understanding of how or what completing the square means, we need to understand what we mean by the square. So let's take a look at, for example, the square of a binomial. This is going to be x plus 3 times x plus 3, and when we multiply using FOIL, x times x is x squared plus x times 3 is plus 3x plus 3x plus 9. And so we get x squared plus 6x plus 9 when we combine those two 3x's. Let's do another one. X plus 5 squared. That's x plus 5 times x plus 5. So we've got, oops, I don't need parentheses anymore. X squared plus 5x plus 5x plus 25. In other words, we got x squared plus 10x plus 25. Now, the thing to notice here is that when you have a, and these two, this and this, those are called perfect square trinomials. They're trinomials because they have three terms. They're perfect squares because they came from the square of a binomial. Perfect square trinomials. Now, in these perfect square trinomials, we want to notice that the 6 is the 6 and the 10. How did the 6 and the 10 compare to the 3 and the 5? The 6 and the 10 are double the 3 and the 5. And the 9 and the 25, well, that's the 3 squared and the 5 squared. So that's why this completing square works the way it does, is because we're going to go backwards. We're going to go from this to the perfect square trinomial to the binomial squared. And so we need to set it up so that it is a perfect square trinomial. And it's a perfect square trinomial when this number, notice that 3 is half of the 6. So you've got to take the 6 and divide it by 2. And then take that number and square it. If you divided 6 by 2, you get 3, and you square the 3, and you get the 9. So if the constant is the square of half of the x coefficient, then you've got a perfect square trinomial. So that's what we're going to accomplish with this trinomial. Now, the first thing we do though is we open up. Well, we leave a space here. We add this 24 to both sides so that we can leave a spot here to complete the square. We'll want to complete the square, and this is actually the same as the one of the ones I just used. This 10, the x coefficient, needs to be divided by 2 to give us 5, and then you square the 5 to get plus 25. Now, we've added 25 to the left side of the equation. That means we have to also add 25 to the right side of the equation, or it won't be balanced anymore. Now, by adding that 25, we created a perfect square trinomial here. And as we recall, that's x plus 5 squared. So the left side of the equation is x plus 5 squared. It's like factoring. What time x plus what? X plus what? We're playing the factoring game. What two numbers add up to 10 and multiply 25? 5 and 5. So we've got x plus 5 squared, and that equals 49. And now you solve by taking square roots, which is another skill that has been learned in the past, hopefully. So we take the square root of both sides. Well, what two numbers could the x plus 5 be? The x plus 5 What two numbers times themselves get 49? It can be positive 7 or negative 7. So x plus 5 could be positive or negative 7, which means that x could be, we subtract 5 from both sides, and we've got negative 5 plus and minus 7. So we've got negative 5 plus 7, negative 5 minus 7. Negative 5 plus 7 is 2, negative 5 minus 7 is negative 12. So those are our two solutions, 2 and negative 12. And I see I'm past the 10-minute mark already, but there's nothing magical about 10 minutes, so let's do one more example. Let's take x squared plus, let's go minus 5x. Minus 5x equals, hang on, let me see if I can get this. Actually, I want to be x squared minus 11x equals negative 21 fourths. Let's see, make sure that's the right one. Yeah, okay, so now we take, first we need to give ourselves a little bit of space here. So if you're doing it on paper, you want to leave space to complete the square. We have to find a constant that will make this a perfect square trinomial. To do that, you simply take the coefficient of x, divide it by 2, and then square it. So what's half of negative 11? Half of negative 11 is negative 11 halves. If you square negative 11 halves, well, you're going to get a positive because negative times negative is positive. You'll get 121 fourths, so plus 121 fourths. But we have to add 121 fourths to the other side as well. That comes out nicely. So now, x, so what is this perfect square trinomial? What is it the square of? Well, this guy is always the guy that ends up right here. Half of this guy, half of the x coefficient, is the constant in the binomial that's being squared. Look here. 5 is half of the 10. So when you divide the x coefficient by 2, that number is the constant in the binomial that's being squared. So now this is negative 21 fourths plus 120 plus 121 fourths. Well, that turns out nicely to be 100 fourths. So x minus 11 halves, we take the square root of both sides. This could be positive or negative, whatever multiplies by itself to get 100 fourths. That will be 10 halves. Well, gee. Yes, 100 fourths actually, duh, is 25. And so really we're talking about plus and minus 5. So so that means we add 11 halves to both sides. We've got, but I'm going to leave it as 10 halves because it's going to make it easier. We've got 11 halves plus or minus 10 halves, 11 halves plus 10 halves, 11 halves minus 10 halves. 11 halves plus 10 halves is 21 halves, and 11 halves minus 10 halves is 1 half. So these are your two solutions. 21 halves at 10 and a half, and 1 half. That was pretty tough.